Dear students, we are learning quadratic expressions chapter. In today's video, we are going to learn the important concepts related to exercise 3b. So in that one, first important point is a necessary and sufficient condition for the quadratic equations a1x square plus b1x plus c1 is equal to 0 and a2x square plus b2x plus c2 is equal to 0 to have a common root is c1a2 minus c2a1 whole square, which is equal to a1b2 minus a2b1 into b1c2 minus b2c1. So this is the important condition. To these equations, these two quadratic equations have common root. So let us suppose that there is one common root, that is alpha, to this equation and this quadratic equation also. So as alpha is the root of quadratic equation 1, then it should satisfy. That means we will get a1 alpha square plus b1 alpha plus c1 is equal to 0. That is one equation, and this alpha is the root, also root for second equation, that is a2 alpha square plus b2 alpha plus c2 is equal to 0. So solve these two equations, then you will get this condition. So the condition is c1a2 minus c2a1 whole square, which is equal to a1b2 minus a2b1 into b1c2 minus b2c1. Remember that condition. So here now I am not focusing on proof of this theorem. So you can verify from the textbook. Next, some properties of quadratic equations. First point, when a not equal to 0 and c not equal to 0, b is equal to 0, we say that ax square plus c is equal to 0 is a proper quadratic equation. Students, in this video I am focusing on important points, very important points, which are very useful in competitive examinations as well as in intermediate public examination also. So concentrate and try to understand the concepts. So here, as ax square plus bx plus c is equal to 0 is a quadratic equation. In this, if b is equal to 0, then this term goes vanish. Then what is remaining? Ax square plus c. In this one, a is not equal to 0 and c is also not equal to 0. Then we will get one quadratic equation. This is also quadratic equation, but with a special name, that is proper quadratic equation, right? So this quadratic equation having two roots. So those are alpha and beta are the roots of this quadratic equation. Then what is the sum of the zeros? That is alpha plus beta is equals to minus b by a. As b is 0, this becomes 0 by a value become 0. Next, product of the roots formula, already we have learnt that alpha into beta is equal to c by a. Next, discriminant. What is the formula for discriminant? That is b square minus 4ac. Delta is b square minus 4ac. As b value is 0, 0 square minus 4ac become minus 4ac. And as a not equal to 0 and c not equal to 0, the product is also not equal to 0. Next, whereas the roots, coming to roots, x is equal to minus b plus or minus under root of b square minus 4ac by 2a. So x is equal to minus b, that is 0 plus or minus under root of b square 0 minus 4ac by 2a. Okay, so these are the two roots. We may if a is negative, c is positive, or a and c are having opposite sign, one is positive, one is negative, then positive into negative become negative, negative into negative become positive. So plus or minus 2 root ac by 2a, 2 gets cancelled, like that you will get. So if they are having same sign, then it is we will get complex roots. Okay, so in anyway, so we will get two same roots which are whose absolute values are equal. So in this case the roots have the same absolute value. Okay, so otherwise from this also we can write ax square is equal to c, x square is equal to minus c by a, and x is equal plus or minus root minus c by a, and the absolute value of this one is x is equal to root of minus c by a. So the answer is depending upon signs of a and c. If a and c are having opposite sign, then we will get surds. If a and c are same sign, we will get negative in the root. Then the answer is a complex number, complex root. Okay, so this is the study of this proper quadratic equation. Next, second point, if alpha beta are the roots of the quadratic equation, ax square plus bx plus a is equal to 0. Here observe, ax square plus bx, in the place of c we have a. So that means the coefficient of x square and the constant terms are equal, whereas this a not equal to 0. That is the condition for quadratic equation. Then the product of the roots alpha into beta is equal to c by a. That means a by a, which is equal to 1. Okay, so in this case constant term and coefficient of x square both are equal. Then alpha beta is equal to 1. So if we bring beta to right hand side, then we will get alpha is equal to 1 by beta. And if we bring alpha to right hand side, we will get beta is equal to 1 by alpha. So we can say that one is reciprocal to other. So alpha is equal to 1 by beta, beta is equal to 1 by alpha. In this case, for example, okay, we will get like this roots 2 into 2 or 1 by 2. X minus 2 into x minus 1 by 2 is equal to 0. These are the two roots, x minus alpha, x minus beta. So x minus 2, 2 LCM, 2x minus 1 is equal to 0. This becomes 0. X into 2x, 2x square minus x minus 4x plus 2 is equal to 0. So 2x square minus 5x plus 2 is equal to 0. So here this is of the form ax square plus bx plus a is equal to 0. If the coefficient of x square and constant terms are equal, then we will get two roots which are reciprocal to each other. In this case, each root is reciprocal to other, and neither alpha nor beta is 0. So here if beta is equal to 0, it is not defined. If alpha is equal to 0, not defined. And also we can say that the product is 1. Therefore alpha not equal to 0, beta not equal to 0. Next point, in the quadratic equation ax square plus bx plus c is equal to 0 with a not equal to 0 and c not equal to 0. These are the important conditions, remember it. This is the behavior of different types of values and quadratic equation. In this case, if the signs of a and c, the symbols of a and c are same, means both are positive or both are negative. If both are positive, then c by a, positive by positive, become positive, greater than 0. If both are negative, negative by negative become positive only. Okay, in this case, if the roots are real, if the quadratic equation having real roots, then they have same sign. For example, so x square plus 5x plus 6 is equal to 0 is a quadratic equation. In this one, a value 1 and value of c is 6 and c by a is 6. 6 by 1 is 6, which is positive. A is positive, c is positive, then the ratio is positive. The roots, after solving this equation, we will get two roots. Those are minus 2, minus 3, both are having same sign. So in this case, the roots are real and they have the same sign. Okay, like this. If the signs of a and c are a value 1, c value minus 6, signs are different, one is positive, one is negative, then the ratio is automatically negative. Positive by negative or negative by positive become negative. Okay, hence in this case the roots are in opposite sign, different sign. So after solving we got 3 and minus 2, so they are indifferent. So like this, without solving we can say the behavior of the roots if you remember these points. Okay, so like that, identify understand the each and every property with examples. Next, fourth point, if the coefficients and one root of a quadratic equation are real, then the second root is also real. So ax square plus bx plus c is equal to 0 is a quadratic equation if a, b, c are real, and also one root, we will get x is equal to minus b plus or minus under root of b square minus 4ac by 2a, right? So in this one, if one root is real means if x is equal to, if we get 5, then other root also real, that means we may get 7, so both are real, like that we will get. So in another way, then the second root is also real. If one root is real, the another root is also real. Otherwise we will get like this, 2 plus or minus root 3, 5. So 2 plus root 3 by 5 one root, 2 minus root 3 by 5 another root. So if one number is real, then another number is also real number. These two are surds which are conjugate to each other. 2 plus root 3 by 5, 2 minus root 3 by 5. Like that we will get pairwise conjugate roots. Okay, so this is the surd and this is conjugate, like that we will get. So if we will get complex number 2 plus 3a, like this, 2 plus or minus 3a by 2. So sometimes we will get, if we will get here, if one root is real, another root is also real. If one root is complex number, for quadratic equations we will get only two roots. If one root is real and another root is also automatically real. If one root is complex number, then another root is also complex number and both are conjugate to each other. If one root is 2 plus 3a by 2, then another root is 2 minus 3a by 2. If one root is a plus ib, then another root is a minus ib, like that we will get. Next, some notes. Let f of x is equal to ax square plus bx plus c is equal to 0 is a quadratic equation, and alpha beta are the roots of this quadratic equation. Then first condition, if c not equal to 0 and alpha beta not equal to 0, as c not equal to 0, automatically the product of the roots is not equals to 0. Means already this a must and should be not equal to 0, as it is a quadratic equation, and c not equal to 0 means alpha beta is equal to c by a, which is not equal to 0, and f of 1 by x is equal to 0 is another quadratic equation. If we replace x with 1 by x, we will get f of 1 by x is equal to 0. This is an quadratic equation whose roots are 1 by alpha and 1 by beta. For example, if f of x is equal to x square plus 5x plus 6 is equals to 0, then the roots are x is equal to minus 2 comma minus 3. Now by substituting here, this is f of x and this is f of 1 by x is equal to 0. Here roots are alpha beta and here roots are 1 by alpha and 1 by beta. This is f of x is equal to 0. By replacing the x with 1 by x, we will get 1 by x whole square plus 5 into 1 by x plus 6 is equal to 0. We will get 1 by x square plus 5 by x plus 6 is equal to 0. Here x square is the LCM, 1 plus 5x plus 6x square is equal to 0. It becomes 0. Finally we will get 6x square plus 5x plus 1 is equal to 0. After factorization you will get minus 1 by 2 minus 1 by 3 are the roots. So if minus 2 comma minus 3 are the roots of f of x is equal to 0, then minus 1 by 2 by comma 1 minus 1 by 3 are the roots of f of 1 by x is equal to 0. In the similar way, f of x minus k is equal to 0 is an equation whose roots are alpha plus k and beta plus k. So that means here I am taking k is equal to, then f of x minus 2 is equal to same equation, x minus 2 whole square plus 5 into x minus 2 plus 6 is equal to 0. After simplification you will get two roots, those are 0 comma minus 1. So these are minus 2, minus 3. Now minus 2, minus 3 are alpha, beta plus k. What is the value of k here? 2. That means plus 2 plus 2. Minus 2 plus 2 0, minus 3 plus 2 minus 1. So the resultant zeros are 0 comma minus 1. So if you practice more, you can write, you can estimate the roots in easy way. Okay, so if we have x plus k, then we will get alpha minus k comma beta minus k. Okay, next third point, this is f of x, and if we find f of minus x, then the roots become just with the negative sign. The roots of quadratic equation ax square plus bx plus c is equal to 0 or alpha beta, then the roots of f of minus x are minus alpha minus beta. That's it. Okay, for example, just now we have seen f of x is equal to x square plus 5x plus 6 is equal to 0. The roots are minus 2, minus 3, and if we replace x with minus x, you will get f of minus x is equal to this equation. The roots are x is equal to 2, 3. Only the change is at sign. And if k not equal to 0, divide with k, then f of x by k is equal to 0. The roots are k into alpha and k into beta. If we divide with 2, here we have quadratic equation f of x, here we have quadratic equation with f of x by 2. So x by 2 whole square plus 5 into x by 2 plus 6 is equal to 0. After simplification, you will get a quadratic equation, and x is equal to minus 4 minus 6 are root. That means twice minus 2 and twice minus 3. Twice minus 2, twice minus 3. That means if we divide x with 2, then the roots are multiples, k alpha, k beta. If we divide with k, we will get k into alpha, k into beta. So remember all these important points. Next, three important rules about sign of quadratic equations. So let a, b, c are real numbers where a not equals to 0, and ax square plus bx plus c is equal to 0 is a quadratic equation. Then first one, the roots of ax square plus bx plus c is equal to 0 are non-real complex numbers. The roots are complex numbers. When the roots are complex numbers, if discriminant is negative, then if and only if ax square plus bx plus c and a have same sign for every x belongs to R. If and only if means, so here I am taking x square plus 2x plus 9 is equal to 0 as example. Then the roots are complex roots. So here observe, a is equal to the coefficient of x square, a is equal to 1, which is positive, then automatically the sign of quadratic expression is also positive for every real number. If we substitute any real number, the sign of this quadratic expression is always positive. For example, substitute 1 square plus 2 into 1 plus 1 2 plus 9 11, positive. If we substitute negative also, you will get positive. Okay, so in this case we will get like that. So here I have taken minus x square plus x minus 5 is equal to 0 as a quadratic equation. We got complex roots. So here as the a value is minus 1, which is negative, then for every x belongs to R, the quadratic expression have negative sign only. Why means a is negative as per rule. Ax square plus bx plus c and a have ax square plus bx plus c and a have same sign. As a is equal to minus 1, which is negative, then automatically this is also negative, right? So like that we can say that if ax square plus bx plus c is equal to 0 or having non-real complex roots, then if and only if these two are having same sign for all x belongs to R. Students, remember this important point and practice twice or thrice until get the clarity. Next, second important point, if the equation ax square plus bx plus c is equal to 0 has equal roots. In the previous point, they are having non-real complex roots. Here has equal roots. Then this quadratic expression and a have the same sign for all x belongs to R except x is equal to minus b by 2a. Students, already I said that if the condition was mentioned, you have to think about that. If here the condition is except x is equal to minus b by 2a. If we take x is equal to minus b by 2a, what happens? In that way you have to think. Okay, I will say now here x square plus 2x plus 1 is equal to 0 is a quadratic equation having equal roots. The roots are x is equal to minus 1 comma minus 1. So x is equal to minus b by 2a means that is minus b 2 by 2a 1. So we will get minus 1, that is the root. So if we substitute x is equal to minus 1, what happens? The answer becomes 0, which is neither positive nor negative. We cannot decide sign there. That's why this is the exceptional case. Okay, now in this case this is a quadratic equation, right? So in this quadratic expression, if we substitute any real number except minus 1, then all are positive. So as the coefficient a is equal to 1 is positive, this quadratic expression gives all positive values only. Okay, so if this value of a is negative, then the resultant quadratic expression value whose roots are real and equal, then the sign of that quadratic expression also negative. If it is positive, if a is positive, a means the coefficient of x square is positive, then the quadratic expression is also positive for all real numbers. If the coefficient of x square a is negative, then the value of the quadratic expression is also negative for all x belongs to R. Remember this. Here one more important formula, that is let ABC belongs to R and A not equals to 0 such that the equation ax square plus bx plus c is equal to 0 quadratic equation has real roots. So in the first case non-real complex roots, in the second case real and equal roots, in third case real and distinct roots. Those are alpha and beta, where alpha is less than beta. Alpha is small root, beta is large root. Okay, so these two are the roots. Alpha is minimum, beta is maximum. Then here we have two conditions. If we take any real number between alpha and beta, so if these are two roots, minus 6, 1, if we take between these two, then the quadratic expression and a have opposite signs. Here x square plus 5x minus 6 is equal to 0 is a quadratic equation. X is equal to 1, minus 6 are the roots. Alpha is equal to minus 6 and beta is equal to 1. Right? Now I am taking a value 0 which is lies between alpha and beta, that is minus 6 and 1. Now substitute 0 in the quadratic expression, we will get answer as minus 6, which is negative. So the value of this quadratic expression is negative, whereas the coefficient of x square is 1, which is positive. So the quadratic expression and a have opposite signs. So as alpha is equal to minus 6 and beta is equal to 1, if we take any value between minus 6 and 1, that means minus 5, minus 4, minus 3, minus 2, 0, and substitute in the quadratic expression, then always you will get negative only. Y means a is positive. These two are in opposite sign as per first point. Okay, so the value for x lies between alpha and beta, then quadratic expression and a have opposite signs. If a is positive, then this is negative. If a is negative, this is positive. Okay, remember that thing. Next, if this x is not lies between these two, that means it is outside. outside, means that is less than, x is less than minus 6 and x is greater than 1. So less than minus 6 means minus 7, minus 8, minus 9, like that. Greater than 1 means 2, 3, 4, like that. From that I am taking 2. Okay, you take any value. I am taking 2 here. Okay, then substitute 2 in this one. You will get 2 square plus 5 into 2 minus 6. The value is 8, which is positive. The value of the quadratic expression after substituting x is equal to 2, which is greater than 1, is the result as positive. And whereas the coefficient of x square, that is a is equal to 1, is positive. So both are having same sign. A and quadratic expression having same sign. So that is the point. For x less than alpha, this is alpha, this is beta. X less than alpha, any value less than alpha and any value greater than beta, then the value of the quadratic expression and value of the a, coefficient of x square, both are having the same sign. This is very, very important. So these 3 points are very, very important. So I have explained with suitable examples. Please go through those examples. So these concepts are important in competitive examinations also. Now one more important concept, that is maximum and minimum value of parabola. Suppose that a, b, c are real numbers and a not equals to 0, then f of x is equal to ax square plus bx plus c is a quadratic expression. Okay, so this is of the form y is equal to ax square plus bx plus c. You are familiar with that quadratic expression. If we draw the graph for that quadratic expression, then we will get a parabola, which already you drawn in 10th class standard, 10th standard. So here one important condition, this is quadratic expression ax square plus bx plus c. In always the graph is in the shape of parabola, that may be open upward. So these are the graphs, open upward and sometimes open downward also. So when the graph open up, when the graph opens down. So if a greater than 0 means the coefficient of x square is positive. That means 2x square plus 3x plus 5 or minus 5, like that. So these symbols are not at all matter if the coefficient of x square is positive. Okay, then the parabola open upward, So as it is open upward, it increases infinitely, but here we will get minimum value. The graph is decreasing and increasing. So in this case we have minimum, absolute minimum. Okay, next, in this case also this is the minimum point. This point is called as a vertex of the parabola. The parabola where it changes its direction. So it is decreasing and increasing. So where it changes its direction, so that point is called as vertex of the parabola. Okay, so here at the vertex of the parabola we have absolute minimum. So this vertex, the point of vertex is known as minus b by 2a. Okay, so this is minus b by 2a, x is equal to minus b by 2a. So x is equal to minus b by 2a is the axis of symmetry. So if we fold like this, then it is symmetric with respect to x is equal to minus b by 2a. Okay, and the minimum value at x is equal to minus b by 2a is 4ac minus b square by 4a. 4ac minus b square by 4a is the absolute minimum value. Where it exists at x is equal to minus b by 2a. Important point, minus b by 2a comma 4ac minus b square by 4a is the absolute minimum, and x is equal to minus b by 2a is the axis of symmetry of the parabola. This parabola open upward. Okay, so how can we get that x is equal to minus b by 2a means? So once recall the knowledge of applications of derivatives which you learned in previous intermediate first year derivatives, applications of derivatives. So as f of x is equal to ax square plus bx plus c, and after differentiate with respect to x, you will get a into x square derivative 2x plus b into x derivative 1, c derivative 0. Why I am differentiating here? So at the first derivative we will get critical points or stationary points. At that stationary point we will get maximum or minimum. Okay, so this equate this f dash x to 0. So then 2ax plus b is equal to 0, then x is equal to minus b by 2a is called as critical point. At this critical point we will get maximum or minimum. Then the differentiate again with respect to x, you will get again 2ax derivative 2a. Okay, as a is positive, positive into positive, positive. As you learned in intermediate first year geometry in differential intermediate first year B paper, that is different applications of derivatives. In that second derivative test tells us if the double derivative is greater than 0, the function has minimum at x is equal to minus b by 2a. So then find the minimum value by substituting this x is equal to minus b by 2a in the function value. Listen, so f dash x decides where the minimum exists. F double dash x decides at the critical point minimum or maximum exists, decides. Now f of x decides the function value, how much the value is, how much, like that. So f of x is equal to a into minus b by 2a whole square plus b into minus b by 2a plus c. So a into b square, ab square by 4a square. Next b into b minus b square by 2a plus c. So 1a gets cancelled. Now what is the LCM? 4a. Here we have b square minus 2b square plus 4ac. So finally we will get 4ac minus 2b square plus b square minus b square by 4a, that is the value, minimum value. Okay, so this type of parabola having minimum value, but it does not contains maximum value, as it is increasing infinitely. Okay, so as x approaches to infinity, parabola graph ax square plus bx plus c also approaches to infinity. As x approaches to minus infinity, the graph approaches to plus infinity only. Okay, so like that we can solve. Now in the second case, if a is less than 0, then f of x having absolute maximum value at same point and the value is also same. Okay, so if a is equal to 0, the parabola open downward. Okay, if a is negative, like this, if we have minus 2x square plus 3x plus 4, so if we draw the graph for this quadratic expression, we will get parabola open downward. That indicates it is increasing and decreasing. The parabola where change its direction is called as vertex of the parabola, and the vertex is minus b by 2a exists at, this is the absolute maximum point, this exists at x is equal minus b by 2a, and the value is 4ac minus b square by 4a, that is the absolute maximum which exists at x is equal minus b by 2a, and here x is equal minus b by 2a is the axis of symmetry of the given parabola. Okay, so how can we find in the same way we can find first derivative test, that is 2ax plus b. Okay, after equating we will get minus b by 2a, and after differentiating again double derivative is 2a. As a is negative, this is also negative into positive, negative. As double derivative is negative, so at x is equal minus b by 2a, double derivative negative means it indicates maximum exists. Okay, so if you go through first year applications of derivatives, you will get this clarity. Okay, then substitute this x is equal minus b by 2a in this one. So just now we have substituted, and in this case also we will get same value. So maximum minimum exists at x is equal minus b by 2a, which is called as vertex of the parabola, and the value is 4ac minus b square by 4a. Students, remember all these important points and recall the points. So based on these concepts, we will do problems in next video. Okay, thank you.